Professor Yao, thank you very much for inviting me here today. The title of my talk is What Are My Odds? And I think that's appropriate. I think my luck is actually running rather bad today because I've been chosen to follow such an erudite and entertaining lecture by the previous speaker. But hopefully I'll be able to impart a little bit of interesting information to you if I can. The subject is going to be historical and modern efforts to win at games of chance. And the things that are going to be discussed are how gambling and a desire to win at gambling inspired the scientific study of probability. I'm going to talk about three key mathematical concepts that emerged during that early study which describe the majority of gambling phenomenon. And then I'm going to talk a little bit about some modern contributions of mathematicians to solving present-day gambling problems. Everything begins with gambling, or at least the important modern history begins in 1654. And there was a well-known gambler in Paris named Chevalier de Marais, and he was perplexed by a seemingly inconsistent result in some of the popular games of chance that were played at the time. The illustration on the left is not really the Chevalier, but it's a person in the costume of the time, so that may be what he looked like. His particular question that he was dealing with was a game of betting on rolls of dice, and his question was, why, if it is profitable to wager that a 6 will appear within 4 rolls of 1 die, then why is it not profitable to wager that double 6s will appear within 24 rolls of 2 dice? And the reason is because both of those represent 4 rolls of a dice represent 2/3 of the possible combinations on a 6-sided dice, and 24 rolls represents also 2/3 of the total ways that 2 dice could come out, which is a total of 36 combinations. Now, he thought those should be the same. Now, de Marais took his question to his friend Blaise Pascal. As we all know, Mr. Pascal was one of the greats of mathematics, so de Marais was very lucky to have him as a friend. Stimulated by de Marais' question, Pascal began a very now famous chain of correspondence with another mathematician of the time, which is Pierre de Fermat, of Fermat's last theorem, who was living at that time, and the two of those were friends. Now, in their discussions, and the letters have been examined by historians of mathematics for many years, but it was evident that to those two that no existing theory existed that adequately described a solution to de Marais' problem. What resulted was a chain of correspondence extending for some years, but all of the important ideas, or I should say the important ideas for a foundation of the theory of probability, resulted from that correspondence. The three key concepts I'm going to talk about that relate to practical problems in gambling are 1, probability, 2, the concept of mathematical expectation, and 3, what's known as the law of large numbers. Firstly, probability. The early work on probability dealt with games such as dice tossing games, or dice rolling games, or coin tossing games, where the game could be broken down into a certain number of equally likely possible outcomes. For instance, a die has 6 sides, and if you roll 1 die, then there are 6 possible outcomes. Any one of the 6 numbers could come up. And the probability of a particular side coming up is given by the number of sides or the number of events that cause that to be true. So on rolling a dice, the chance of a 5 coming up, for instance, is 1 out of 6, because there's 6 possible outcomes, all equally likely, and one of those corresponds to winning. So the probability in that case would be 1 over 6. A further refinement to the definition of probability, I should not say a refinement, but an extension, is to say that the probability of any event can be limited to or can be expressed as the limit of the number of successes or successful outcomes over the number of trials. And if you see, looking back at this, the form of that equation is very similar. This is more of a generalization of the theory to say that it's the limit of an observed frequency can be also thought of as the probability. The second very big idea that's very relevant to gambling problems is the idea of mathematical expectation. Now, this idea was first attributed to the Dutch mathematician Christian Huygens, who is pictured there on the right. And now the definition of mathematical expectation, which I'm sure you're all familiar with this concept, being mathematicians, is it's a weighted average of a random variable. And that equation at the bottom expresses the expectation of a random variable x is simply the various values that x can assume each times its probability of occurring. So p sub 1 times x sub 1, p sub 2 times x sub 2, etc., summed together, and that would be a kind of weighted average outcome. And the reason that is so important for gambling is because the result of a gamble can be thought of as a random variable that can assume various values. In this case, usually winning or losing, for instance. So if we look at the probability for, let's say, the return on a particular bet, there's a certain probability of a profit, so p times the profit, plus 1 minus p, which would be the opposite probability, or the complementary probability of a loss, and that would equal your expectation. And to make that a little bit more clear, I've worked it out there in numbers at the bottom of the screen for the case of a bet on roulette. Now, on a roulette wheel, as I'm sure you're all familiar, or you know what one looks like, there's 38 possible numbers, and if you win, you get back a net win of 35, and if you lose, you lose the unit that you bet. So a particular bet at roulette, you have a 1 in 38 chance of winning a 35 profit and a 37 in 38 chance of losing your $1, and that all averages out to a net return of minus 0.0526. So your expectation for placing a bet on a roulette layout would be to lose 0.0526, that fraction of your money, basically. So it's a negative expectation. Another property of expectation, which is very, very important for the gambler, is that expectation is additive. When you make a series of bets, each one of those will have a specific expectation. Your overall expectation, that is your overall average or mean result for a series of gambles or a series of plays at a particular game, is going to be simply the sum of the individual expectations of the bets you made. And so that leads to a rule number 1, as I'll call it, which is that the only way to achieve a long-term expected profit in gambling is to make a series of bets that have a net positive expectation. Now, the last of the 3 big concepts I wanted to talk about is the law of large numbers. And this is one way of naming this particular phenomenon. But now, gambling typically involves playing a series of repeated trials of a particular game. That could be bets at the horse races, or plays at the blackjack table in the casino, or plays at the roulette wheel. And that had been, independent trials or repeated repetitions of an experiment had been studied quite carefully by Bernoulli, Jacob Bernoulli, that is, one of the Bernoulli brothers. And in fact, the outcomes of repeated trials are often called Bernoulli trials in honor of Jacob Bernoulli. And down below we see the famous formula, which is the binomial distribution, and that is a formula which tells us the probability of particular numbers of successes in a given string of trials. Now, again, I think as a group of mathematicians you know much of this, but as the number of trials increases, the expected ratio of successes to trials converges stochastically to the expected result. So in this case, I'm showing a series of results, and what's graphed there is the proportion of successes, and they're clustering there around the 50-50 or the 0.5 point. Excuse me. So tying these 3 concepts together, being able to express the chance of an event as a probability allowed the mathematical analysis of any wager. And the additive property of mathematical expectation enabled the calculation of the overall expected result of a series of wagers. And the law of large numbers guarantees that the actual result of a series of wagers is going to converge